Hello and welcome my Math 140 students. This is Cindy Enrigue, your math professor, and we will be going over section 5.5, which is multiplying polynomials and special products. So here we're going to get used to multiplying our polynomials together. So hopefully we know somewhat how to do this. So what we do is we actually multiply the numbers together and we're going to add the exponents together. Now, you don't have to do this, but it might be helpful to see what you're doing. So we're going to take this 5z to the fourth and we're going to multiply it by each and every single term that we have. So essentially this 5z to the fourth is going to get multiplied by that 4z to the 3. That 5z to the 4 is going to get multiplied by that negative 7z squared. That 5z to the 4th is going to get multiplied by that negative c. And that 5z4 is going to get multiplied by that negative 8. So this might help you to kind of organize your work a little bit. So I know that 5 times 4 is 20, and I have z to the 7th power. Here I have negative 7 times 5, which is a negative 35, and I'm going to have z to the 4 plus 2 power, which is 6. And here I have a negative 1 times 5, so it's a negative 5, z to the 5th power. And 5 times 8 is 40, and I have a z to the 4. So now I know exactly how each term is going to look like. And all of these have different exponents. So I know my final answer, I'm going to have a 20z to the 7th minus a 35z6 minus 5z to the 5th plus a 40z to the 4th. And so that's going to be my final answer. Now, I'm looking at number 2, and I'm like, okay, well, now I have a trinomial times a trinomial. So that might be a little bit more involved, but it's still doable. What I'm going to be using here is something called the box method. That's going to help me to just keep everything organized. So I'm going to write the first polynomial going straight across. So I'm going to have my t squared. I have a negative 2/3 t. And I also have a negative 4. Going down, I'm going to write the second polynomial. So I have a 4t squared. I also have a 6t. And I also have a negative 5. So this kind of helps me to kind of organize what I'm multiplying together. So now it's going to kind of be using a multiplication table chart, except now I have polynomial terms. So in this square, I'm going to have 4 times a 1t squared, which is a 4. And if I add my exponents together, it's a t to the 4th. And this one, 4 times a negative 2/3 is going to give me a negative 8/3 t to the 3. And 4 times 4 is a negative 16, and I have that t squared. And over here, I'm going to have 6 times 1, which is a 6t to the 3rd power. Over here in this middle box, 6 times a negative 2/3 actually ends up becoming a negative 4. And t times t is t squared. Negative 4 times 6 is a negative 24, and I have that t there. I have negative 5 times 1, so it's a negative 5t squared, and negative 5 times a negative 2/3 is going to be a positive 10/3 t, and I have negative 5 times a negative 4, which is going to give me a positive 20. So now I can look at this and I can see, hey, there's actually a pattern. I have my degree 3 here, and I also have my degree 3 in here. So I can kind of see that it kind of goes in this diagonal. So I'm like, okay, that kind of helps me. And I also see that my squares are also in a diagonal. Pretty cool. And then I have my t's in a diagonal as well. So that's going to help me to at least be organized in how I'm adding all of my numbers together. So I definitely know that I have a 4t to the 4. Now I'm going to add. I'm going to have my positive 6 plus my negative 8 thirds. That's going to give me a positive 10 over 3t to the third power. And now I have my t squares, so I have a negative 5 minus 4 and a negative 16. So that's going to give me a negative 25t squared. Next, I'm going to have my positive 10 thirds, and it's going to be added by a negative 24. That gives me a negative 62 over 3t, and I still have my positive 20. So I kind of like to use the box method. So again, this is something called the box method. When I have a lot of terms that are being multiplied, it just helps me to be organized, and it makes it not so scary. And the way, if you did it correctly, the way it works out is that you actually have your diagonals that you're going to be adding together if they all have a degree 3 or degree 2 or degree 1. So I really do like this method. But of course, the choice is yours. The next thing I want to be going over is FOIL. Hopefully you've heard of FOIL. FOIL kind of represents this first, the outer, the inner, and the last. This is how you're going to be multiplying some numbers together. So it's often used when you multiply two binomials together. That's what FOIL really represents, when you're only multiplying two binomials together. So here I have a p plus 5 times a p minus 2. So here's going to be my first. P times p is p squared. Now I'm going to have my outer, so that's a negative 2p. Then I'm going to have my inner, that's a positive 5p. And then I have my last, which is a negative 10. So when I combine like terms, those two are going to combine. So I still have a p squared plus 3p minus 10. So that's going to be my final answer. And if you're like, okay, well, I like FOIL, or maybe you're saying, no, I don't like FOIL, that's okay. If you still want to go back to the box method, we can still do the box method. That is the beautiful thing about math, is that there's not just a one approach. There's many approaches to get the same answer. So here I'm going to have my 4r minus 3, and I have an r and my negative 1. So now I can go ahead and multiply these together. So I'm going to have a 4r squared, a negative 3r, a negative 4r, and a positive 3. And again, the really nice thing about this is that I'm actually going to have the diagonals, these r's, that are going to combine together. So that makes it really nice. So now I have a 4r squared, a negative 7r, and a positive 3 as my final answer. So for part C, I'm going to go ahead and do the box method. I mean, why not? I'm already there. So I have A, and I have my 4B. I also have another A, and a negative 3B. So when I do this, I'm going to have an A squared, a 4AB, a negative 3AB, and a negative 12B squared. And of course, the beautiful thing about this is that your middle terms here are going to go ahead and combine together. So I'm going to have this as an A squared. 4 and negative 3 is going to give me a positive 1AB, and I still have that negative 12B squared. So that's going to be my final answer. And if you're like, wait a minute, Cindy, I really want to do the FOIL. Well, that's fine. We can still do FOIL. So if I do FOIL, then I'm going to have a positive 6xy. My outer is going to give me a positive 10x. My inner will give me a positive 27y. And my last is going to give me a positive 40. So here, I actually don't have any of the terms that are going to be added or subtracted. It can't be combined because all of the variables are different. And so that's as far as I can go. So, moving on. Now what we're going to have is we're going to have the product and the product of the sum and difference of two squares. So what's really cool about this is that you actually see that these are conjugate pairs. The conjugate pairs are exactly the same except for the sign in between. So this is an addition and that's a subtraction. But the really cool thing about it is that whenever you multiply conjugate pairs, the two middle terms are going to cancel out. So you're just left with the first thing squared and the last thing squared. Let me prove it to you. Here, if I were to FOIL this all out, I would get this as a z squared plus 9z minus 9z minus 81. And what we see is that positive 9z and negative 9z actually cancels out. So I'm left with a z squared minus 81. So it's all about noticing that these are conjugate pairs and the middle terms are going to cancel out. Well, you're like, wait, Cindy, maybe you're just getting lucky. Well, let's see. If I were to FOIL this out, I would get k squared minus 7k plus a 7k minus 49. Again, the two middle terms cancel out, so I'm left with a k squared minus 49. So hopefully now you're starting to believe me. And so here, I'm going to have this as, well, let's see. I have 8 times 8, which is 64, a positive 8p, a negative 8p, and a negative p squared. And lo and behold, the two middle terms cancel out because one's positive, one's negative. So I'm left with a 64 minus p squared. So I'm just left with the first thing squared and the last thing squared. So now that we're starting to really understand and see this trend, whenever I have these conjugate pairs, I can say, hey, the middle terms are going to cancel out. So these are definitely my conjugate pairs. So let's think about this. Let's think about the first thing squared. So if I have the first thing squared, so if I'm thinking about FOIL, f is the first thing. So 3c times 3c, well, that would give me 9c squared. And since they're conjugate pairs, I know that the outer and the inner are going to cancel. So the last thing I'm looking at is last. So the last term, 4 times negative 4 is a negative 16. So I know that my final answer is 9c squared minus 16. That's just a way to think about it whenever you see that conjugate pairs. If you don't see the conjugate pairs, that's fine. Eventually you'll end up at the same answer. You're just going to have two extra terms that are going to eventually cancel out. So for number 5, we still have our conjugate pairs. So I can kind of use my shortcut again. So I know that I'm going to be doing the first thing. So 4/7 m times 4/7 m. Well, 4 times 4 is 16. 7 times 7 is 49. And m times m is m squared. And I know it's going to be subtraction. And the last thing over here is n times n, which is my n squared. And that's only if you recognize that conjugate pairs, the middle term is going to cancel out. Well, now we're going to be squaring a binomial. Now here, you can think of this as a shortcut. And to tell you the truth, all of my students in Math 140, even 45, even my calculus students, they don't really like this shortcut. They would rather get the problem right and not use a shortcut, so they're going to have to actually rewrite this binomial twice. So this square means there are 2 parentheses, okay? So this is r plus 10, that's 1, times another r plus 10. So, oops, sorry there. So when I multiply this out, I'm going to FOIL. And when I FOIL, I'm going to get my r squared plus 10r plus 10r plus 100, which gives us r squared plus 20r plus 100. And if you're like, wait, what about that shortcut? Well, the shortcut is saying that it's a squared, the first thing squared, which is here, twice what you have in here, so 10 times r, twice 2 times 10 is 20, and then square the last thing, which is 100. And if you're like, whoa, that didn't make any sense, that's okay. I'm not really showing the shortcut anyways. I'm showing you how to do it the correct, long way, and that's fine. So here again, I have the exponent 2, so I'm going to write it out. So this is h minus 1 times my h minus 1. So I'm going to go ahead and FOIL this out again. So I'm going to have my h squared minus h and plus 1. So now I have h squared minus 2h plus 1 as my final answer. And on the next page, we do have some practice problems, but there's only certain ones that I want to really get into. So for example, I really want to do number 4 and number 7. So number 4 and number 7. So this number 6, I really don't want to use it at all. Let me see if I can erase it. Nope. Okay, so I'm just going to kind of black it out here. So don't worry about that number 6. I need more room for number 4 anyways. So what this is saying is, hey, this is an exponent. That's 3. So I'm going to write this out 3 times. This is r plus 5 times r plus 5 times an r plus 5. So I need to multiply 2 of them first and then the third one. So the best thing I'm going to say is multiply the last 2. That way it makes it a little bit itsy bitsy easier for you. So when I FOIL this out, I'm going to have an r squared plus 5r plus 5r plus 25, which gives me r squared plus 10r plus 25. So all of this is going to be multiplied by my r plus 5. So okay, I'm thinking about this. So I'm going to have r get multiplied by everything. So I'm going to have an r to the 3rd power. I'm going to have a positive 10r squared. I'm going to have a positive 25r. Now on the next one, I'm going to have the 5 times everything. So I'm going to have a 5r squared. So I'm just going to write it down below. It's a positive 5r squared. So I'm aligning the coefficients, or sorry, I'm aligning the exponents. Now I have 5 times 10r, which is going to give me a positive 50r. And 5 times 25 is a positive 125. So when I add those 2 together, I'm going to have r cubed plus 15r squared plus 75r plus 125. So that ends up becoming my final answer. So remember, this was actually 3 binomials being multiplied together. So I FOILed the last 2, and then I multiplied the binomial by that trinomial to get that polynomial there at the end. And another way you could have done this is using the box method whenever I have a binomial times a trinomial. So for number 7, I look at this and I'm like, you know what? I don't want to do that stacking method that I did over here. So this was called the stacking method. And maybe you didn't like lining up the exponents, and that's fine. We can go back to the box method. So if I go back to the box method, I'm going to rewrite this. So I'm going to have my 3x squared, a positive 5x, and a negative 4. I have x, and I have 2. Okay, so now I'm going to be multiplying these things together. So I'm going to have a 3x cubed, a 5x squared, and a negative 4x. Down below, 3 times 2 gives me a 6x squared, 5 times 2 is 10x, and negative 4 times 2 is a negative 8. And again, the beautiful thing about this is that you see that these things get added in this really cool diagonal. So there's one diagonal, and here's my other diagonal. That's just to kind of help me be organized and what I'm adding and subtracting together. So I'm going to have my final answer was 3x cubed. Now I have that 6x squared and 5x squared, which is a positive 11x squared. Positive 10x minus 4x is a positive 6x, and a negative 8. So that's another way of multiplying a binomial times a trinomial, is just go ahead and using the box method. Okay? And for the last problem, section number 8, that's just a trinomial times a trinomial, and really you can do the box method there, and I think this is where I want to stop for section 5.5.